Now that we have learned how to estimate using on-screen take of both linear dimensions and area dimensions, it's time to move on into the foundations to estimate the area of the foundation, estimate the volume of concrete, estimate the weight of the rebars, and also the contact area for the formwork. In the set of drawings we have architectural drawings, we have also civil drawings, we have surveys, we have plumbing, electrical, and so on. Under the S structural drawings, we have the foundation plan. There is a lot of sections and details, and then we have schedules and notes. We'll start by looking at the foundation plan, which is drawing S1. Drawing S1 shows the foundations for the multi-purpose building. At first, this drawing looks very complicated and difficult to understand, but as we look and read at the notes and the different shapes, patterns, and symbols, we will understand the information that the architect wants to communicate with us. We'll start by looking at the scale, and this one is 1/8 to a foot, and we have in our software 1/8 to a foot scale, so that seems to be correct. Next, what we want to do is we want to make sure that the dimensions in these drawings are correct, so the scale matches the actual dimensions given by the architect. For example, here we have a dimension of 22 feet. We will use the dimension tool to measure this distance, and yes, it's 22, so it seems to be correct. Then we have a vertical dimension of 6 feet here. We're going to measure that here, and yes, it is 6 feet. So we do trust that both the horizontal and vertical scale are correct to be 1/8 to a foot. Then we notice that there are different shapes and different formats for information. So we see these type of shapes indicates a different type of masonry wall. We see that they have here TEs that indicate concrete slabs. Then we have this hexagonal symbol that indicates footing designation, circular one that indicates a column designation, and they ask to see structural notes for additional information. So we need to look at those drawings. Here we have hatching patterns for slab on grade, and then these have different elevations, so we could understand a little bit better what the architect is showing. We see here there are these hexagonal symbols. There is a symbol E, symbol B, symbol F, A, B, F, C. So there are different type of foundation. All of these foundations will have different dimensions and specifications. So we are going to start by looking at the other foundation drawings that we have. There is on the cover sheet, it says schedule details and notes are in drawing S7. So we'll go to drawing S7 and look at the foundation schedule. This foundation schedule tells us that these marks, hexagonal marks, correspond to this size of foundations, and then they have this type of reinforcement. So for example, foundation A will be a 1 foot 6 inches. This will be wide by continuous, so it's a continuous footing, 12 inches deep, and it had originally a 3 bars number 4 on the bottom. These are continuous along the foundation line, but the architect made a revision and said no, the foundation is going to have 3 number 5 bars continuous at the bottom. So that's how this footing schedule is read. We can choose some spot footings. These are easy to estimate. We have these type E. It's a 5 foot by 5 foot by 18 inches deep with 8 number 5 each way, top and bottom. So it has 8 bars, number 5, looking north, south, east, west, both at the top and at the bottom. So that means we have 16 bars on the bottom, 16 bars on the top. That would be 32 bars in total for that foundation. Foundation F, it's again a 5 by 5 by 14 inch deep, and it has 6 number 5 bars each way on the bottom. So we can estimate those since they are spot foundations. They're easy to estimate. We'll go back to S1 and see if we can find these foundations. So we have foundation E, we have foundation F, we have foundations C, different types. We'll start with the foundation F. So because this is a one spot footing, we can estimate how many of those have, and then find out both the area, the contact area for the formwork, the volume of the foundation, and also the weight of the rebar. We'll create a new condition. It's going to be called a count condition for foundation type F. This foundation, we can create a note down here. It's a 5 foot by 5 foot by 14 inches using 6 number 5 each way on the bottom. So now we know what is the description of this foundation. We know the size. It's going to be a 5 foot by 5 foot, so we enter here 500. That means 5 feet 0 inches. The height is 14 inches, and it's a square in shape. So we can click apply, OK, and then basically count how many of these we have. So that's how we will do a counting condition to count foundations that are spot foundations. If we want to do continuous foundations, it will be a similar process. So we see here we have a foundation type B. If we go to the S7 drawing that gives us the details for the foundations, we see the foundation B is 2 foot wide by continuous by 12-inch deep, and it has 3 number 5 on the bottom, continuous. So we could create a new condition also for B, but now because this is a continuous foundation and not a spot footing, we should create a linear condition that will measure the length of this footing, and then we can estimate, given that length, the width and the height, the volume of the concrete contact area for formwork, and so on and so forth. So we're going to create a new condition. This is going to be a linear condition. The linear condition will be called foundation type B. We said this foundation is 2 feet wide, so the 200, it has a height of 12 inches, and then the reinforcement is 3 number 5 continuous on the bottom. So now we know what type of reinforcement it has, the width, the height, and we can then start estimating. We can say this is a foundation type B, this is a foundation type B, so we can start on this end and start estimating foundation B all the way up until we find a different type of foundation. Like here we have a foundation F. So we'll stop at this outer edge of foundation F. This section here is also foundation B, so this will go all the way to the end here, and then from this middle point all the way to the end. We have to be careful on these corners, not to double count the corner. If we go all the way to the end and then from here all the way to the end, we will be double counting this corner. So if you see, here is another example. We have a corner. We use the vertical line to estimate the foundation all the way to the edge, and then when we want to do the horizontal side of the foundation, we'll start on the inner edge and then move all the way where we have foundation B. It should stop over here, and then we don't overcount the corners. So if this is foundation B again, we can go from the inside all the way to the corner, and then go from there to the outside. But then see, we have a foundation C here, so it's better to stop our foundation B on the edge, because this is 2 feet wide and foundation C has a different width. So this section over here is considered foundation B. It stops on the inner edge, and then the rest from this line to this line is foundation C that goes along east-west. So right now I have 101 linear feet of foundation type B in my estimate. I will let you guys work on this and estimate the rest of the length for that foundation.